Hi, I'm Alani from Akash, and in this video, I'll be briefly discussing persistent storage. Managing storage is a distinct problem from managing your compute resources. Persistent storage can help protect critical data from eviction while reducing the chance of data loss. Persistent data is data which you want to be available even after you fully close and/or restart your application. Furthermore, it should be available even after power to that device is shut off. It's also sometimes referred to as non-volatile storage. Magnetic media, such as hard disk drives and tape, are common types of persistent storage, as are the various forms of optical media such as DVD. In today's world, persistent storage systems can be in the form of file, block, or object storage. In containerization, persistent storage refers to storage volumes usually associated with stateful applications such as databases that remain available beyond the life of individual containers. These volumes can be contrasted with ephemeral storage volumes that live and die with containers and are associated with stateless applications. For the most part, storage persistence is a given, the very basic requirement of any storage system, whether it refers to a single drive, a shared network storage system, or a cloud storage service. Because persistence is assumed, it's rare that it's even mentioned among the technical specifications for storage devices. Now, there is an exception related to recent developments in virtual computing that has helped raise storage persistence as an issue. In recent years, containerization has become a popular way to bundle applications with the operating systems into discrete, transportable modules that can be created and destroyed as often as needed. But containers initially did not support persistent storage, which meant that the data created with a containerized app will disappear when the app finished its work and the container was destroyed. However, new methods have been developed that enabled you to retain the data created by container applications, and you can maintain it in familiar storage volumes. Storage volumes are usually associated with stateful applications such as databases. These remain available even if the application is shut down or finishes its processing. These advances in storage for containers solve the problem of retaining ephemeral storage volumes that live and die with the stateless applications that are run from containers. Solid-state drives are also examples of persistent storage, but they differ from the other forms of persistent media in that they do not have any moving parts, either internally or with the drives required to access the media. Basically, less moving parts equals increased performance. This includes efficiency and longevity. Some types of solid-state storage, notably the chips used for RAM and cache systems, are typically non-persistent storage devices. This means the data they hold is erased when continuous power ceases to flow into those devices. However, certain types such as non-volatile RAM and flash-based RAM are persistent. Typically, they rely on battery backup power when the main source of electricity is cut off. Of course, volatile or non-persistent storage resources have one advantage. Since they lose all their data when power is cut off, they generally present less of a security risk compared to persistent storage equipment. Stay tuned.